here's what I'm gonna bring you guys specifically about me. Oh, yeah. So, all you have to know about me, right? Specifically where I come from and all that, it doesn't matter. What matters is that I'm not Estonian. Oh, surprise. But I have been living here for like 6 years or something. I've been working in the industry for 5, and I have gotten 2 degrees cum laude, one from TalTech and one from Tartu. And right now, while working in the industry full-time, I am a full-time doctoral student as well. And so what specifically are we going to talk about? So first, we're going to talk about studying in UT versus elsewhere. I'm not going to name any specific institution in the country. However, you may draw your own conclusions. And then I will talk about working full-time while studying, which is something that a lot of people ask me once they got to know about my situation. And then after that, we're going to talk about what I did in Pipedrive, which is a project that I could very, very hands-on utilize almost exactly what I research. So to start off, so the following 2 slides are my own opinions. They do not reflect, represent, or endorse or are endorsed by neither the University of Tartu or Pipedrive. Big disclaimer here, right? This is my own opinion. I'm not going to say anything insane, but I'm just saying, right? Don't go to Tartu saying this isn't that. No, that's my opinion. Nor to Pipedrive as well. So to start off, let's start off with why did I choose to study in the University of Tartu specifically after studying in TalTech. So the reason that I chose Tartu is very objective. So there's a couple universities in the country, and one of them is objectively in a completely different league than all the others, right? And as a foreigner, you have to constantly think about your survival, right? That I particularly really despise my home country. I absolutely do not want to go back there. This is my main goal in life, I would say. How can I find the best way to never have to come back? And when you get a title from a very prestigious institution, which the University of Tartu is, immigration-wise, right? This is seen as really, really good, not only in Estonia, but for many different countries. So, for instance, if you're in Estonia and you get a job, if you lose your job, you have 3 months to figure your life out. This is very little time. However, if you get a degree from the University of Tartu, then let's say that things don't work out in Estonia, then you could, for instance, immigrate elsewhere quite easily. Canada, for instance, has very good immigration schemes if you have a master's degree from a reputable institution, most specifically from the top 300 and else. So primarily, one of the reasons was that I wanted a good title. The second reason was that there is a very, very high integration between research groups and teaching. So in case you have even a vague interest in research, then you can very easily approach any member of the faculty, me included, and just ask to take part in some research. Oh, and it is even likely that you might get some sort of non-trivial scholarship, in the hundreds of years, in the low hundreds of years out of it. So this was something that I took a lot of advantage during my master's studies and even before, because I actually did my bachelor thesis in the University of Tartu. And since then, I have taken advantage over that. And so, if it was easy for someone external, then you can imagine how much easier it is if you're internal to the university. So this is definitely a high point, because at the same time that I was working in the industry and studying, I managed to even get some research experience. And the people at university are kind enough that they can even count this research experience you have as part of credits. Depends on your arrangements. But yeah, so main point to take here, the university is very welcoming to people that have interest in general. And the third point is that very few classes that I've taken had hard requirements for being present, and this is really important because I have some deep issues with attention and with showing up to class, and because of some actual issues. And I've never had any trouble with that in a university at all. I just did not show up to a lot of classes. I didn't have to, in some of them, I had to justify, but when I had to justify, everyone was very welcoming. As long as you're getting good results, things are right. So I would say that out of all universities I've studied, this is by far the most welcoming place to people that have some sort of issue as well as I do. And the next step is that if you're a person like me, that you just do not attend classes, then you need to have good quality materials. You need to have good quality materials. You need to have teachers that answer you, teachers that are available and all that. And I found this here with the absolute highest quality. Every single time I felt like I needed some aid, I was able to get it. This is quite different from my previous experiences in a country. And another thing, which is really great, is how the university has high standards for planning. So whatever you see on courses.cs.ut, it is usually the canonical information. And very often, there's quite a lot of stuff available in advance of the semester starting. So one of the ways in which I managed to get ahead is just by studying early or just looking at previous years' courses or something, materials. So the university is quite organized with the teaching materials, which is extremely important, especially if you want to get ahead, right? And the last point is that there's very reasonable scholarship opportunities. I would say that this is a very meritocratic institution. If you're willing to be in the top 10% of students, you will be rewarded. And this is very, very important because this keeps up the motivation, right? That you're seeing physical rewards for it. Now, the next part, which is working full-time while studying. So once again, this is very specific to me, but this is what worked out for me. So it is definitely possible. And I would say that it is optimal, my own personal opinion. So it is doable if the most important part, you're a grown-up adult, right? That you do not have procrastination issues. I have seen a lot of presentations by fellow doctoral students and else sort of glorifying procrastination as something unavoidable. But I would say no, absolutely not. It's just a matter of going to therapy. Really, I go to therapy a lot. I recommend everyone, if you struggle with procrastination, don't look at memes. Go to therapy, really, in general. So if you're able to deal with the biggest issue, procrastination, then you can officially arrange your time such that during daytime, you can work, and during the evening, up to the time that you sleep, you can study. To me, it has worked really well. Once again, after a lot of effort. And this is the first step, right? To be able to actually delegate significant amount of time, as in basically your whole day after you come from work, to your studies. The second part is that you need to know how to shortcut, right? Sometimes you will not be able to learn everything to get the grade that you want to have. But still, in my opinion, you should always strive for the highest grade, because once again, you get financial incentives for doing so, being very cynical, right? Aside from the reward itself and the title. And so at some point, you have to reason about how much study and what should I study enough to be able to get the grade that I need to get. So this is a very important part as well. This is the shortcutting aspect, is that you need to accept that you will not learn everything that you might want to learn, because the goal is different, right? Depending, taking into account that given that you're working, you don't have all the time in the world to leisurely learn everything. So, and the third aspect is that I think it's really necessary for your job to be symbiotic with your degree, right? I have always worked as a programmer in the IT sphere. So pretty much every single thing that I've learned, I could somehow shove it in my job in some way or the other. I'm always surprised when people say that whatever they learn in university, they don't manage to use. But I think pretty much the opposite. Just about everything that UT has taught me, I have seen it somehow in practice in one way or the other. And so these are the requirements that I would say, right? So the first requirement is don't glorify procrastination. It's an issue. Go see a therapist. The second one is know that you have to shortcut. The third one is to, if you get a job, please get a job in actual computer science. And the last part is accept that you will not have much of a social life. Accepts that you will not party now, but it's not because you're not going to party now that you can't party later. So yeah, I guess these are the main points regarding is it possible? And then now the benefits of working full-time while studying. So the main benefit, I'll say it's the biggest benefit, is that you will be able to learn the theory and have it fresh in your mind for your work. This is a huge advantage, you know, really, really huge advantage, that maybe you see some weird graph algorithm or something, and then at your work, you realize that just about everything is graphs. And then that weird graph algorithm, maybe it's quite simple to use a library and use it somehow and leverage, right? If you're working in a large corporation where there's a lot of room for optimization, then this is a huge advantage, really. It really is, when you understand that there's more to life than a race. You know, it truly is. And the second benefit is more of a hard pill to swallow, which is that really nothing beats hands-on experience on a job. And a lot of people that I meet and all that, because of the way that lobbying works, a lot of companies which have connections to the universities in general, they are big corporations. You know, they lobby, so the university uses the software, they teach about their tools and all that. And so researchers, they usually have agreements to research with the tools that these companies use. But that's not what 99% of the companies use at all. You know, okay, Google, Microsoft, yeah, they use their stuff. All the other companies, even unicorns, they use very different stuff. And you're not going to learn that in the university. You learn that on the job. And so this is why it is of paramount importance for you to get some sort of job experience while you study. Yeah. And the third benefit is that you will be really ahead of the curve, because just the fact that you have a chance to apply that theory every single day, it's going to stick to your mind so much more than if the first chance to apply it is 2 years after, which by the time that you have the chance, you already forgot it completely, you know? So yeah, these are my very subjective points as to how possible is it to work full-time while studying full-time, and what are the actual benefits. There is 1 million counter arguments and 1 million pro arguments as well. This is just my opinion. Once again, not endorsed by the University of Tartu, nor endorsed by Pipedrive. Now, about the objective part of the presentation, Pipedrive. So Pipedrive was founded in 2010 by 5 Estonian guys. It has 100,000 clients, and its clients are companies. So Pipedrive is a sales customer relationship management tool, which is very similar to some extent to Salesforce, right? However, Pipedrive is focused on smaller companies, hence why also it has a ton of clients like that. It has 1,000 employees, out of like half are engineers, and it is a more than $1 billion company, a success history in Estonia, and it is a very, very big reference for technical achievement in Estonia. We care a lot about writing good software, and Pipedrive, it is very, very heavily reliant on microservices. Pipedrive itself is a combination of more than 750 microservices. And now you might wonder, what is a microservice? So a microservice is an individual unit of function, right? So when you open Pipedrive, that single thing that you're seeing is actually 750 interconnected things. And it has more than 1,500 Git repositories over that. So it is a really, really complex machine, and it's huge. So now, software policy enforcement, what the hell is that? In order for Pipedrive to have software excellency, it needs to have some sort of protocols and system. There has to have standards that must be upheld. You can't just write whatever you want and put it there, right? And so, on average, Pipedrive is quite unique, I would say, in a sense that more than 350 changes on a live application happen every single day, really. It moves at a really, really high pace. Some companies, they change their app twice a year. We change it almost 400 times a day, right? This is a lot. So DevOps in Pipedrive is really, really highly rated. Even in our parent company, which is an American company, we are held as an example to all other companies, basically, because we move at an extremely fast pace. And so, yeah. However, if we move to a fast pace, at such a fast pace, does that mean that, how does that work, right? How can we make sure that we're not breaking the app 250 times a day? How do we ensure that 100% of these 350 deployments are not gonna end up in some sort of broken functionality to the user? And this is extra complicated when you put into scope with the fact that Pipedrive is composed of 750 parts. So the complexity there is huge, because each part can interact with each other. So how can you know? And because of that, we needed to have an actual way to ensure that each and every piece of software adheres to some policies. And clearly, this cannot be made manually, right? So there are two ways that you can enforce these sort of policies. One of them, which is the way that most companies do, which is you create a document and then you make a bunch of conventions there. And then when someone does not meet these conventions, right? Maybe they put something wrong in a repository, made the wrong configuration file, wherever, then you're manually going to find that, and then you're going to annoy the person to fix it. That does not scale, right? Imagine if there were 200 issues a day for half of Pipedrive's microservices. This would require 10,000 checks manual. Now, that's absolutely insane. So the real way to go about it is to actually write software that ensures that these conventions are being followed. And now some questions arise. So how can we write conventions in code? For instance, how can we say that for repositories written with this programming language, deployed in this region in America, in our American servers, they cannot have this and that, or they need to have memory limits or whatever limits and else? How could you describe that? And then the other question is, how can we evaluate these conventions with arbitrary data, right? So how can we evaluate this with any sort of service that has a configuration file, right? How can we evaluate all that? And the third part is, how can we ensure that the evaluation of these conventions with respect to arbitrary data are correct in itself, And then lastly, how can you test that the convention evaluation has the semantics they actually intended to have? So all these questions are really important. And these questions also show just how hard it is for you to do something as general as this is. However, from programming language theory, we know that given the grammar and a language, you can estimate complexity and estimate a lot of things on it. So the answer to the first question is the most important one. The way in which we describe these conventions will have a direct impact on the evaluation, on the testing, and on correctness. So if you get a way to describe the conventions in a way that theoretically it is correct, then boom, you've already solved the biggest issue. The other three issues come for free. Now, I'm going to show you guys how it was done in the first way. So the first solution was called DORA, which stands for Deployment or Repository Analyzer. It was written entirely in JavaScript, and the conventions themselves, they were written in documentation, and then there was a code implementation on how to evaluate that over the specific data that it needed. So for instance, this convention right here, just don't look at the code. Just notice that it's there. So what this bit of code does is that it gets two files, and then it looks a specific line in each of these files, and then compare them if they have the same value or not. So in order to do that, it needed 30 lines of code. And out of these 30 lines of code, there was only one line, which was about the logic of the rule itself. You know, there's one line over these 30 lines of code, which actually do this very simple logic check that is in there. So this means that 90-something% of this code is useless, right? If we can theoretically use a way to evaluate conventions, then we don't have to write all this, because all this boilerplate is writing the evaluation of the rule, not the logic of the rule. You know, the logic of the rule is a really, really small bit. The evaluation and else, it all comes right there. So how can we make this more robust? Because the least code you have, in principle, the more testable it is and the more focused it is, the room for error is smaller. So the next solution that we did was to look quite deeply in programming languages and look into what is the domain in which we can leverage the most out of existing tooling, even if it might be experimental. How can we leverage the proper state of the arts to scale our rule evaluation, right? Because this is extremely brittle. Not only is it brittle, but it was really hard to test, you know, like really, really hard to test. And then we found that from my previous research, I've been working with this very, very specific kinds of query language called Datalog. And Datalog is a really interesting query language. Actually, it's a mathematical formalism, which it is specifically made for data which is outlined as facts, you know. So you have some facts, which are things that you know that are true. And based on these things that you know that are true, Datalog, it provides you some theory and what it means to evaluate that correctly. And there are multiple algorithms on how you can do this evaluation correctly in the same way. So we decided to leverage that in order to model our issue of policy enforcement as something that could be solved within the theoretical framework of Datalog. And how did we do that? So almost every other configuration file is YAML, JSON, or TOML, or something similar. And all policy enforcements, literally every single policy enforcement, it takes some sort of external data, right, such as from an environmental variable, and then it gets that and compares it with some sort of local file. And then it takes some sort of decision such that, is there a problem here or not? If there is a problem, should we stop this from being deployed to live, or should it be deployed for testing even? Maybe should stop right there. And with Datalog, we answered the question of what should be done by putting these configuration files as facts. So we used a Datalog compiler, which it is able to read JSON files as facts. So what we did was that we created a rule engine, which given some sort of a rule, such as, for instance, this is the same rule as the previous example. It is quite easy to understand. So the name of this rule is image definition. So first it checks if some sort of file is locally present. And if it is not, then it gets the last image from some file. And then it does some data wrangling on there. It just trims a suffix from the file. And then it compares one file with the other. And depending on the result, it's going to output. This is just for logging, basically. However, if any of these checks right here fail, then the rule has failed. So this is much more concise than here. And given that it is more concise, it is a lot easier to test as well, because this whole compiler, it allows you to do some quite advanced things, such as injecting values in variables and all that. And so you can mock just about every single check here, which means that you can test this really, really easily. It is a bit abstract to see it, but the point is that from the developer experience, testing is extremely important. And this is not testable at all. This is really testable. And it is funny because we only managed to get to this point by actually looking into how to actually do it in the most optimal way within the concept of fitting the problem to what the theory already provides. So yeah, having theoretical and research knowledge, it allowed me to aid the team in finding the perfect hammer for the job. And not only in that, but having the necessary understanding to use it. Because if you have no idea what data log is, if you've never seen it, you're going to be scared. You're going to be like, the hell is that? I don't even understand. I'm not going to read the paper. However, by doing research, I already read the paper. so I didn't get scared. And because of that, we had a really, really successful work. Now, what did we gain from Neodora? By the way, this logo on the right, it is the logo of our tool itself, Neodora. So it is Dora the Adventurer, however, posing as Neo from the Matrix. And so most specifically, let's talk objectively. So it is a lot more efficient than the previous implementation. The original Dora, it used to have a lot of fail positives, and sometimes it just not work because we were mixing a lot of unrelated aspects. It is a lot easier to make a mistake when you have to write the logic, the evaluation, the testing on the evaluation, and asserting the correctness. These are independent things that should be tackled differently. And because it is more efficient, we also managed to enforce these policies much more efficiently. So we actually decreased the number of policy violations across all Pipedrive repositories because we were just getting a much more accurate view of what was going on, And because of the testability and all that, we also had a lot more code coverage in the project itself. This is extremely important if you're a developer who works. You need to be able to have testable code. This is extremely important. On the previous project, it was quite low. It was something in the 30–40% because it was just not easy to test it at all. Things were just built and patched on top of each other. It was not good. And the last aspect, which is the most important one, is that the number of developers complaining about false positives, it has gone to zero. No one has complained about an issue. It has been, I think, more than a month or two, that not a single person has complained. Previously, it was like every other day of the week, someone was coming to our chat and telling us, hey, my deployment is being blocked, because Dora is having a sort of a problem. It is telling something that's just not true. And thank you. That's it. Now I guess we can go for the Q&A.
Okay, thank you so much, Bruno, for this exciting talk. Now it is time for some questions from our audience. And just a reminder, everyone, please type your questions to the Q&A box. So
Okay.
the first question is that did the university help you find a job at Pipedrive?
No, I got it on my own. I know that the university has some sort of internship scheme, but no, as I said, I've already worked in the industry for a couple of years, so I don't think an internship would have suited me.
Okay, thank you. Then a question says that I agree with you regarding the work and study argument, but I would like to inquire you about your perspective in terms of negotiating the time allocation arrangement and in consequence the salary.
So this is an easy question to answer because I can tell you exactly how it works for me. So I have researched a lot, my supervisor, most importantly. I have taken multiple classes with my current supervisor. I have got to know the research group. I have talked about doing a doctorate while working full-time for months with this professor, and he was in full agreement with that, as long as I performed, of course. And so that's how I got it. However, most importantly, it is about putting everything on the table, right? So certain cultures and nationalities, they have very different views on the dedication, on actually not on the dedication, on the amount of time you have to warm your chair. And so I would recommend like that. Be honest with your supervisor before he becomes your supervisor, right? If you want to work one day, then tell him that, because of these cultural differences. In some nationalities, it's just not acceptable to do something aside from your doctorate at the same time. So yeah.
Okay, thank you.
What did that answer suffice or?
Yeah, I think it did.
Okay.
So what do you personally like the most about Pipedrive? Why do you think it is a good company to work for besides it's a unicorn?
So I am very money driven. Honestly, cash is the main thing. I'm very direct. I like the cash. I like the money. But of course, that is not everything. That is like 80%. The other 20% is that it is a company that respects you a lot, in the sense that they give you a very long noose for you to hang yourself or to swing with it. So since my very first day, I had 0 people telling me what to do. They have thrown a ton of things in front of me, and I picked what I wanted to do. And this amount of trust is really great. It is really, really great. I would say that I have the same in the university. I believe my supervisor gives me a lot of trust in the same way, I would say. So I would say that's the thing that I like the most, that I have both in Pipedrive and in academia, exactly the same way. I have a lot of trust from people. There are other places that I've worked at where I had no trust at all, or that I've had less trust. So yeah, I think trust is the best thing.
So you mentioned that it's good to work and study at the same time, so you can immediately implement what you're studying, not after 2 years. Can you maybe give some examples from your own experience, something that you studied and immediately implemented at your job?
Yeah, absolutely. So probably the first thing that I like from when I just arrived from my just started in my job, it was actually, we have some analytics in our tribe. Tribe is a team in Pipedrive. It's all just a team in my team. And there were a bunch of questions. I'll say specifically. So in our deployment system, we had to run some analysis on a lot of data, right? On a lot of data that has some strong correlations. However, if you do it naively in the usual ways, then you're not going to find out much, even though you know that there's something there. So I distinctively remember from a machine learning class on how you could actually use some really, really basic algorithms to actually get some quite nice insights, some very, very basic stuff. And then after that, there were a couple projects that I've taken part in where you can get some absurd performance improvements just by using the most suitable data structure. And sometimes it can be some quite exotic stuff, right? Some quite exotic stuff. However, what was possible for me to, what enabled me to do that is also this trust aspect, right? Because whenever I mention some crazy approach, sometimes people would say, try it, right? Just go on. However, this was not the case in some other places I've worked at. In some other places, they'll just shut me down immediately, right? However, this was not the case in Pipedrive because I have I also take care of some very simple analytics things, and I've gone crazy on that here, really, in Pipedrive, this analytics aspect. I use so many experimental things and whatever and so on, and everyone is like, great, great job, keep it up. We're actually getting something out of that, so it is great. It is great. Even, and it's funny because this is quite unrelated to my main duties, but this is also another thing that I enjoy about Pipedrive, which is how you're allowed to have other focuses than your main one. I would say that 80% of your time is your focus, and the other 20%, it is not badly seen if you spend it on something that will pay out dividends in the future, in innovation in a company in itself. Another thing is about graph algorithms, most specifically in certain projects, actually quite recently. So soon enough on the engineering blog post and Pipedrive, I will post a article which is about how we used a very, very, very opinionated approach at dependency injection to make Pipedrive's own Golang library to write Golang frameworks in general. So, and it is quite, and the idea came from the design and analysis of algorithms class by Vitaly Skacek, where he taught us absolutely everything about graph theory. And then I learned about isomorphisms and a lot of things about paths and graphs. And believe me or not, I applied this directly to writing very testable dependency injection. So stay tuned to the Pipedrive engineering blog post if you want to see that.
Okay, thank you. So the next question is that, do you think that someone who has a bachelor's in electrical engineering, but not necessarily in computer science, would have a chance to enroll for this course?
Oh, wait, I think we skipped a couple. I think a couple questions were skipped from Anna Branet.
I'm going to go back to them.
Oh, okay. Yeah. So, yeah, I actually had a bachelor's in integrated engineering. I did not have a bachelor's in computer science when I got in. And I actually got full scholarship when I got in, and the monthly scholarship as well. So I don't think it necessarily matters. In fact, I would say the electrical engineering is all closer to computer science than my bachelor's.
Okay, so what do you think? Is Estonia really e-Estonia in your opinion? Or is it as digitally developed as said? What services do you like the best?
Absolutely. I've lived in the United States. That's a part of my family's at, and they also live in Canada, and it beats the living crap out of these places. You can do absolutely everything online. Everything, really. I've never had to do anything in paper. And as I've said, I've been living here for 6 years. Nothing. I've never gone to any office aside from like once or twice to renovate my visa or something. And what services do you like the best? All of them. All of them can happen online. It's amazing. I hate these short interactions with people in government offices. They're not happy. I'm not happy. Most often I just woke up. They also woke up. So yeah, it's great. Truly, it is more digitally developed than what they said.
Okay. So could you talk a bit about the program, like describe the computer science program structure a bit? How much time did you spend studying per week, and how were the exams conducted at your program?
Yeah. So the program was basically 75%, no, 70% was about actual coursework, and then some other 15% was about other 10% was about some internship or some actual hands-on work, and the other 20% was about writing your master thesis. And how much time did I spend studying per week? A lot. You're looking at around 50, 60 hours a week or more. I studied a really, really, really a lot. I had no time for anything. Absolutely not. Whatever the teacher said you'll take, it took me 5 times more. Like I really, every time I heard an estimation, I would laugh and cry and laugh and cry. Really. And the exams conducted, sometimes they were online, but all theory exams were conducted in person.
Okay, so during the studies, was there a topic you had not enough time to study at the university due to working full time at the same time? Was there a topic like that?
Yeah. Some more theory-oriented classes, classes that require proofs and all that. I absolutely had no time to study enough, so I quite literally memorized the proofs. I memorized the proofs and then tried my luck to replicate to pretend that I'm able to reason about what is being asked. And I got an A in all classes aside from one, so it worked sort of. But I would say that a big chunk of working has been luck as well.
So did you conduct any exchange studies during your master's? If yes, where and how did it go for you?
No, I did not. I don't recommend you to do that. Because okay, you're gonna go on an exchange. One again, my personal opinion, not the same as the university, nor as Pipedrive. Let's put this disclaimer here. I don't think you should do that because you're gonna go to another country, you're gonna party a heck lot, and wherever. And in this time that you're partying away, you could have searched for a company to work in Estonia or something, or yeah, I would say that like there's much better uses of time than that.
Okay, so there are a few questions actually about the Estonian language. Have you studied it? Can you speak it? And what do you think? What is the availability in the job market in Estonia if you don't speak Estonian?
Yeah, I have studied Estonian. Yeah, ma räägin eesti keelt, okei, ma ütlen. But it is extremely hard. It's the hardest thing I've done here by a massive margin. And the availability in the job market, absolutely. No tech company requires Estonian. Okay, maybe one or the other, but if they do, they're not the ones paying the most and not the ones you should be applying to. So if you want the good cash, then you don't need Estonian. But still, it is your duty as someone who supposedly wants to integrate to society to learn Estonian as fast as you can.
Okay. So can you give your try in predicting the next trends for students to engage in the realms of computer science, owl space or decentralized services and so on?
Oh man, that's hard. I don't think I can give a satisfactory answer on that actually, but definitely, um, decentralized computing is in everything. It is in AI, it is in regular software engineering. So I would say that if you want to focus on something, don't focus on machine learning or whatever. Focus in learning about decentralized computing, which, by the way, is one of the focuses we offer in the computer science masters in UT.
And another question is about what do you see yourself doing in 5 years from now?
5 years from now, I expect to have finished my doctorate and to be fluent in Estonian.
That sounds great.
It does.
I'm not sure if you mentioned that, but how long did it take you to find a job after graduation from your master's? And what do you think, what kind of profile is Pipedrive looking for in their candidates from your own experience?
So it took me 0 years to find after my master's because I got it before I started. But from when I arrived in Estonia to do my bachelor's, it took me a year after, and I wasn't really looking actively or anything, It was like just applying randomly. I would say that the job market is extremely good here.
And if you could give any advice to your freshman year self, what would you say?
So go to the therapist earlier. I started to see the therapist in my first year, and I wish I could have seen it earlier. Really, it really helped me a lot. Once again, do not glorify procrastination. It's terrible.
Mm. So, in your opinion, how expensive do you think is it to live in Estonia?
So let's talk about my numbers. When I arrived here, I was living quite a nice life, spending around 400 euros a month total, including, and I did not live in a dorm. I did not want to. However, nowadays, I think you should add another 200. But if you're living in a dorm, I know of people living on 300 or 350. So, yeah.
Mm-hmm. Okay, so I have a few questions myself. So what are you the most proud of from your experience in studying at the University of Tartu?
What I'm the most proud of is just how much I have managed to get acquainted with in research. Is that truly, I feel like the university, I didn't think I would have managed to get to be this close to research anywhere else in the country, for sure, like this. The environment is great. Almost everyone is available to talk to you. You just gotta knock on their door and they're like there for you, really. It's great and it feels really intimate as well.
Okay, good. So there is a question about you mentioning a therapist multiple times. So how difficult is it to find a therapist who speaks English, in your opinion?
I would say it's easy. I've never even come across one that doesn't. But it's usually because I usually go for a therapist that are young. And so naturally, everyone who is under like 50 in Estonia speaks Estonian. So yeah. But then I have heard people having different experiences as well. But in my experience specifically, it was easy.
Okay. So there is a question, what is your advice for someone who doesn't really know which aspects to specialize in? The person who asked the question is finding it hard deciding what to work on, either data science, machine learning, or working on developing APIs. So what do you advise is the best way to get into the computer science world?
So I would say that the best way is whichever way it's going to get you your job the fastest. And I guarantee you, it is not data science or machine learning. Working on developing APIs and writing microservices and else, that will land you on the job market faster than anything else. So I'd say focus on that. Everything takes development, even machine learning and data science. And the development guys are always going to be employed.
Okay, great. So what do you think, how is the social life in Tartu? What kinds of things are there to do? And what do you like or, yeah, in person?
I would say that the social life in Tartu is great. I I don't have a lot of time, but in a few times that I've had, to just go out or whatever, there's always something going on. And I have quite a couple friends, surprisingly, and a lot of them seem to have no complaints about having stuff to do here like that. I mean, it's the main university town in Estonia, right? So I would say it's quite good. I have lived in Tallinn as well, and I would say that it was easier to find things to do here than there, surprisingly. Mostly because everything in Tartu is very clustered in one street only. So if you go there, there's always something going on.
Yeah. Okay, so I think we covered most of the questions from our audience. We have to wrap it up. So I would like to thank our presenter, Bruno, for a great talk and our audience for being with us today. And a few things before we wrap up. If you are a future student and planning to apply to computer science program this year, the application period has already started and the deadline is on 15 March. So, and there is also going to be a virtual meeting with the program director where you can ask any questions you have regarding the program. And we will send you the information along with a recording of today's talk by Bruno. So thank you again to everybody for joining us today, and have a nice evening.
Thank you.
Thank you. Bye.
Bye.